So now that we've taken a look at some of these changes, let's take a look at how this has been implemented into Lakes Environmental's AERMET View version 9.7. So here we have AERMET View, and I'm going to open up a sample project that I have started to build with a very simple setup with just a single ASOS station. Here you see it as Reno, Nevada, the Reno-Tahoe International Airport, which is an ASOS site. So I've already run AirMinute as well to refine the wind speeds and wind directions. I have the upper air data located here. Everything is set up and ready to go, including some additional processing options, such as the use of the Adjust U Star option for low winds, the 10-meter anemometer height is noted, and the threshold wind speed. Then I come to my sectors, and this is where we start incorporating those surface roughness calculations. I click on the AERSURFACE button to open the new AERSURFACE utility, and this is going to look a bit different if you've ever utilized the AERSURFACE utility within AERMET View. Whereas before, it was a fairly simple window with just a couple options to go through. We've now expanded it quite a bit with a very large preview window so that you see exactly where you are calculating everything for, and a number of tabs to introduce all of these new options that are once available. So it defaults to the 13016 version of AERSURFACE. We switch that over to 19039 draft. We can apply a title, something we could not do before, which can help clarify what this run was, what it constituted, what options, etc. And then for the station location, it takes it directly from the surface station that I've input. So it just reads these latitude, longitude coordinates as they are entered on the surface pathway, and I can just copy those over if I needed to. But we can see here from the preview window, we now have the ability to import mapping data so that we can precisely locate this Met Tower. When you think about the fact that the default surface roughness calculation radius is 1 kilometer, little deviations in the location of that station can lead to big differences in the way that surface roughness is calculated. So we want to make sure that the surface station is very accurately located. If I zoom in on this site, this is where the latitude longitude places the Met station. But as I look at that, I can see it's basically on top of a road, which doesn't entirely make sense. I can refine this preview even more by going to the import menu and selecting my tile maps. I already have a street map loaded in, but if I load the Lakes satellite map server in, that will bring in satellite-based imagery to where I can zoom in and with a high degree of precision locate exactly where I want this Met Tower. And obviously there is no Met Tower where this is currently located. So I need to go through and figure out at my site where this Met Tower actually is. I happen to know for this site, it is actually quite a bit to the north in the middle of the runways. So as I scan further north, I zoom in on this little white dot here, and this is what an ASOS station really looks like. So this is the type of equipment you're probably going to be looking for. You can see there's a pretty tall tower based on the shadow there, about 10 meters in height. There's some additional equipment immediately to the south. And this is the location that I'm going to pinpoint for the station location section. And if you notice, just to the bottom of the preview window, you can see the UTM coordinates noted there. So I can use that to refine my station location. I'll enter in the proper UTM coordinates of this station here. So now I've refined where that location is, and this makes a lot more sense for where I'm going to be calculating my surface roughness and other parameters as opposed to the site far off to the south. If I had left those original coordinates, I'd be basing my calculations on a location that is several hundred meters away from where it needs to be. So it is very easy to use the preview window to help refine that location. Another enhancement with this version of AERSURFACE is that it allows you to input the UTM coordinates directly. You don't have to use latitude, longitude, although the conversion will be done for you automatically. The next change is to use land use data. And so before, where I had to use 1992, now I have options to select 01, 06, and 11. And I can use the WebGIS feature to select the data I want to download automatically. It's not something you have to go out and find for yourself. You can download it directly from our servers. And we use the 3 degree by 3 degree dimension tiles to help try and limit the download size and time that it takes. You'll also see from the WebGIS menu the spatial extents that are covered by each of the products. So if you happen to be in Hawaii, for example, you can use the 2001 data. If you are doing a project in Conus or Alaska, you could look at the 2011 data. One thing to keep in mind, though, if you plan on using the canopy and impervious data files, it is currently recommended that you use the same data product year all throughout. So if I want to use 2011 for the impervious data, I need to be using 2011 for the land cover and the canopy as well. And that's the data that we're going to be using for this particular project. So I select WebGIS, canopy, and WebGIS impervious. And the download speed will, of course, vary depending upon whatever network connection you have, but they're fairly small files, just maybe 20 to 30 megabytes or so in size. Next, I go to the climate parameters. These have not changed much from the old version to the new. You select the period, whether it is one period for the entire year, a default seasonal breakdown, or a monthly breakdown. And if you use monthly or annual, you have the ability to redefine your seasonal categories by month using the table below. I'm going to leave the surface moisture option at average at this point, and I will select the arid region, as Reno Tahoe does get about less than 10 inches of rain per year, so that qualifies it as an arid region, although that selection does preclude the use of winter with continuous snow. I'm going to leave my month season assignments at their default. And then I go to the roughness tab to do my surface roughness sectors and calculation methods. If I wanted to use the experimental ZOF method, I could select that option. And for that option, you identify the anemometer height, which for most MET stations is fairly easy to find, although if you are unable to find it, 10 meters is usually a good rule of thumb. And then you enter in this internal boundary layer factor. The default value is 6. And that is based on some research studies which have shown a 60-meter factor, so the anemometer height times the IBL factor, to perform calculations of estimating the boundary layer growth from an upwind fetch. I'm going to choose the default method, which relies on the radius, and here I'll leave the radius to 1 kilometer. The radius within my preview would grow or shrink depending on what value I select, and you can see the acceptable range is 0.5 to 5 kilometers. It's shown here with the default 12 sectors of 30 degrees arc for each one. I'm going to slightly modify that. I'm going to use 4 sectors, and I'm going to place my sectors based on categorizations of similar land use types. So starting from the bottom, switching to 341 degrees, 293, 158, and 35. So with this 4-category breakdown, you can now see those sectors in the preview window. And I've tried to group together like land use. I will also identify this as an airport site, but one of the neat features of the new version of AERSURFACE is that you can define specific sectors as airport and leave others as non-airport. So in this case, my sector 1, which starts at 35 degrees and cycles around to 158 degrees, I will not call that an airport sector because it's mostly made up of tall buildings, and I want those to be reflected in the surface roughness calculations. My second sector from 158 to 293, the impervious surfaces are mostly flat runway. So there I will call that my airport sector. Sector 3 from 293 to 341, again, mostly buildings and man-made structures. There is a bit of airport, but I feel like there's more of the built-up area than there is the flat area, so I'm going to go ahead and leave that as non-airport. And then for the 341 back to 35 angle sector, sector 4, I will also call that as airport because, again, it's mostly predominantly flat runway surface. There's also options, of course, to check all or uncheck all as you see fit. The final tab are the output files. You now have the ability to rename all of the files that come out of AERSURFACE, whatever you best see fit. There are default names assigned here. And the debug files are quite useful for really breaking down by month, by sector, all of the calculation and land use categorizations that AERSURFACE reads and processes. So now that I have filled in all of my data here, I'm going to click Run. Pops up very quickly, it does its calculations, and that's it. It's done. From here, I can go to the output menu, And I have a whole list of files that I can look through to look at my output, whether they are the debug files for the TIFF images, the grid debug files. If I just want to look at the surface characteristics file, for example, this is what that file looks like. And this is the primary output of the AERSURFACE tool. It gives me a summary of the type of information that I input. I scroll down, I see my sectors, which were divided into monthly frequency, and then there's the albedo, Bowen ratio, and surface roughness values by month and sector for my Met Tower location. And you can see how my sectors 1 and 3 have much higher surface roughness values than what I get out of sectors 2 and 4 that I defined as airport. Switching back to AirMet view, all of those values, albedo, Bowen ratio, and surface roughness, have been added to the table here, and I can go through sector by sector to see all of those values divided up by month. Since I have everything else added, all I have to do right now is run AirMet. It runs through each of the 3 stages, stage 1 for QAing, stage 2 for merging, and stage 3 for processing, after which I'm given some statistics about the data set that I processed. Now, another new feature of AirMet View version 9.7 that I'd like to quickly show is this Surface File QA option. When you click this button, it reads the SFC file you just processed. It's also capable of reading any SFC file that you may have, and it prepares an Excel file. And that Excel file is going to contain a quarterly breakdown of meteorological data quality. So it gives you both the count and percentage of missing hours and calm hours, as well as breaking down those missing values by individual parameter. So cloud cover, wind speed, wind direction, temperature, humidity, pressure, and precipitation. We use the code from within AERMET and AERMOD to determine what classifies a missing and calm hour, so that you get the exact and precise percentages that you need to verify the data quality for your particular project. And as I mentioned before, it is possible to use AERSURFACE for locations outside the United States so long as you have a properly built file, and that's where our Land Use Creator comes in. So under the Tools menu, Land Use Creator, you can choose between the 1992 categorization or the 2001-06-11 categorization. So I can come in here, it identifies the location of my Met Tower. I could download from WebGIS different land use sources. So I have all of the NLCD data that can be loaded in automatically. If I'm in Canada, I have EOSD. If I'm in Europe, the Corin 2012 land cover database. And for other locations, the 1 kilometer resolution GLCC database. You can import this data automatically and then use the tools of the Land Use Creator to refine it. So for example, if I wanted to import the existing land use data that I had for my site, the 2011 land cover data file for this location, it comes in and it reads that data file for the 10 kilometer by 10 kilometer area surrounding my Met Tower. But if I knew, for example, that the area around this particular Met Tower, it identifies this primarily as developed open space. But if I wanted to call this block of land something else, I can use my Polygon Select tool to select all of the cells within that region, come to the land use code selection, and modify these to some other category. Like if I wanted to call this grassland instead of what the default values were because I knew that land use had been changed through some method, I could then apply grassland to those cells. Once I finish making all of the necessary modifications that I think need to be made, I can choose a location where I want to save this file. I'll call it example. And then click Save, and it's going to build a completely new GeoTIFF file that I can then come into the AERSURFACE utility and then use that file as the basis for my land cover file here. So it doesn't matter where you are located in the world, you can use this Land Use Creator utility to build the land cover file you need. You won't be able to build canopy and impervious files. Those aren't necessarily required though. So long as you have that land cover file, that's what AERSURFACE needs to perform its calculations. So in AERMOD View version 9.7, Of course, we have the new AERSURFACE utility. We've also updated not only the land use creator, but the land use viewer as well, such as in this image that you see on the screen here. It identifies the different land use categories within that 10 kilometer by 10 kilometer block, as well as showing the surface roughness sectors. So you have a nice image where you can see what the land use looks like according to NLCD for your particular project location. The metadata QA statistics that I showed, that spreadsheet that gets built in AERMOD View. We have some new receptor selection and import options as well to make that process easier. We've enhanced the exceedance plots. So when you set a threshold violation file, the exceedance plot is now refined a bit to look a bit more descriptive of the area that is being analyzed. And there's additional options which you can find in the release notes on our website at weblakes.com. For those of you who are in the US, please recall that we also do sell station-based AERMOD ready metadata that you can use for your projects. We deliver to you the SFC and PFL file formats for years within the 2000s. It goes back to about 2001 up to the most recent year of 2018. If you would like us to use the 19039 draft AERSURFACE for your processing, just let us know. We're capable of doing that. And you can go to our website as shown here, weblakes.com, under the services metadata section, where you are taken to the order metadata quote form. You fill out that form, we'll get you a quote back quickly. And most of our station-based AERMOD ready data orders can be fulfilled within the same day. I want to thank you for attending our webinar today, and you can send emails to support@weblakes.com if you have any additional questions that you would like addressed. And remember, under the Services tab on our website, you can go to our metadata quote request form and get more information there. I hope you all have a great day, and thank you again for attending.